So how much growth you would have over a year if you apply that same periodic growth. And if you wanted to calculate, let's say, period growth is 0.25%, okay? And effective annual rate growth, assume monthly. And most of the annuity problems we're going to have are going to be monthly anyway. But so I'm going to take 1 plus that growth rate, and I'm going to raise it to the power 12 minus 1. Okay, that's annual growth. That simply means if I had $100 and I grew that $100 by 0.25% every month, 1 year from now, that number would have grown by 3.042%, not 3%. It's a little bit more than that because you have growth on growth. Or if you apply it to interest, you have interest on interest. You could also go back from, in fact, since we're smart people, let's go ahead and write a little code. Let's leave that as it is now. Function, come on. I'm going to write a little function for a little task, and I'm going to call this from years to periodic rate. It's going to have two arguments, I year as double, and I frec, let's make it optional. So if I give you the effective annual rate, this is going to calculate what the period rate must be. And formula is simple. Again, I'm a civilized person. I'm not going to type all of this again. There is something called copy and paste. Equals 1 plus I year raised to the power 1 over I freak and minus 1. And I'm kind of also stickler with leaving spaces between different blocks. Spaces are completely unnecessary as far as Excel is concerned, but A, it improves readability. B, it also helps, especially when we do stuff with if statements and such things. It makes finding errors a lot easier. So I have a function that calculates the periodic rate if I give you the effective annual rate. All right. So there's going to be some stuff. I'm going to have p rate. Let's do our local variables as double. P grow as double. In my mind, P stands for period. Number of periods as double. Going back to this formula, this formula that I have written works at a periodic level. Okay? If we're doing it monthly, it works, however number of months and using monthly interest rate or monthly growth. That's why I need to change everything to periodic. You're probably saying, if that is the case, why didn't we make the arguments periodic? You have a point, but interest rates are almost always quoted as APR, and typically we think of growth rates as kind of annual numbers. People cannot easily relate to, oh, what's a 0.3% monthly growth? They can't get their heads around it. But it grows 10% a year. People get that. That's why. Otherwise, mathematically speaking, this is completely unnecessary. Just introduce as arguments the period rate and period interest rate, correct number of periods, you're done. But we're not, when we write this function, we're not doing it just for ourselves. We're doing it for other people to use it. If it makes it easier to enter the interest rate as an APR and enter the growth rate as an effective annual rate, then you basically cater to the user. And you make adjustment, small adjustment. As soon as we make that adjustment, we're going to act just like it is a periodic calculation. So like before, P rate is I rate divided by I freak. Number of periods is I time times I freak. And P grow, now I'm going to use my little function. Okay. So I'm going to, yes. Hold on to your horses. From year to periodic rate function, in fact, when you use it in VBA, it already tells you what the syntax is. The first argument is the effective annual rate, which happens to be I grow. And the second one is I freak. Now we converted our problem to periodic stuff. Remember, I told you guys about the philosophy of mathematics, reducing the problems to things you know how to do. We have a formula to calculate present value of an annuity if everything is in period rates and number of periods. But so if I give you a different problem, all you have to do is convert it to that one. The rest is the same, which is what we're going to do now. We're going to basically write the code for that formula, which is not terribly complicated because this thing is present value of balloon. Okay. So let's see. I'm going to do another local variable. Let's call this dim p balloon. So let's calculate that one as well. Well, we have a function that's called present single, right? And in this case, iCash is the balloon payment. I could either use the APR version, but since I already converted into everything periodic, I'm going to use the P rate and Perry and close it. Because in this case, frequency is 1 anyway, so I don't have to include it. So that calculated present value of the balloon payment. So we're done with this part of the code. So it has basically two more pieces, right? So let's go ahead and, handle those two more pieces. And I'm kind of very anal about these things. I like dividing problem into pieces, writing lines of code for them separately and just putting them together. That way, if I make a mistake, I can identify where it was instead of a long line that does something. So let's do this. Dim, I'm gonna call this PCE1 as double. Yes, yes. And piece one is simple. Take the first payment, okay? iCash, divide that by period rate minus period grow. That's first piece. Come on, man, I don't want that. Okay. And now this is going to be the second piece. Basically, I'm going to calculate 1 plus period growth divided by 1 plus period rate. Raise the whole thing to the power t and do 1 over 1 minus. It's not terribly complicated. I need to be careful with my parentheses. 1 minus 1 over